Assalamualaikum and good day everyone. We are from STA150 and here's our group members. In this video, we will explain an experiment that contains STA150, which is about probability and statistics. We conduct an experiment in winning, losing and tying in tic-tac-toe games. In this experiment, we investigate the probabilities of winning, losing and tying in tic-tac-toe games. The goal is to compare the experimental outcomes obtained by repeatedly performing the games with the theoretical probabilities predicted by probability theory. To do this, we conduct a large number of trials, record the result of each trial, which is win, lose or tie, and then compute the relative frequencies of these outcomes. These observed frequencies are then compared to the theoretical values to determine how closely the experiment aligned with expectation. Finally, we analyze the difference between the experimental and theoretical probabilities.
First of all, our objective is to identify the experimental probability of winning, losing, and tying in tic-tac-toe game. Secondly, to determine the theoretical probability of winning, losing, and tying in tic-tac-toe game. Lastly, to determine the difference between experimental probability and the theoretical probability of winning, losing, and tying in tic-tac-toe game.
The methodology for this study emphasizes the use of experimental probability through real gameplay using a tic-tac-toe application. The number of rounds is set at 30 rounds to provide a sufficient sample size for probability calculation while keeping the experiment manageable. Before the match started, choose 2 players. To ensure fairness, both players, Aisyah and Nuha, will take turns being the starting player in each round. For this experiment, Aisyah was assigned as the red colour as a representative colour, while Nuha was assigned the blue colour. In the first round, Aisyah will begin the first move, and in the next round, Nuha will take the lead. This rotation helps balance any advantage normally gained by the starting player and makes the data more relevant. After every game, the outcome will be recorded whether Nuha wins, loses, or the match ends in a draw will be recorded immediately to maintain accuracy. Each round being recorded as proof for the result from real gameplay instead of theoretical assumption. This study effectively applies experimental probability, making it an appropriate and achievable approach for analyzing win, lose, and tie frequencies in a 2-player tic-tac-toe environment.
There were 30 sets in total. For every set, we recorded whether Nuha or Aisyah won, lose or tied. Since it's a head-to-head game, Nuha's wins game means Aisyah's lose, and vice versa. If the game ended a draw, both players are marked as a tie. In this study, two players, Nuha and Aisha, play against each other in 30 trials. The theoretical probability for each outcome, win, lose or tie, is assumed to be 1/3 or 0.33, since each result should have an equal chance of occurring in a fair game. First, let's look at the experimental probability for both players. Nuha played 30 rounds and achieved 9 wins, 4 losses and 17 ties. This gives an experimental probability of 0.300 for wins, 0.133 for losses, and 0.567 for ties. For Aisha, since this is a one-on-one game, her results are the opposite of Nuha. That means Aisha had 4 wins, 9 losses, and 17 ties. So, her experimental probability is 0.133 for wins, 0.300 for losses, and 0.567 for ties. Now, let's compare these experimental probabilities with the theoretical probability of 0.33 for each outcome. For Nuha, both the win and lose probabilities are lower than expected, while the tie probability is much higher than theory. For Aisha, the win and lose probability is also lower than expected, and the tie probability is again higher than predicted. This shows that in actual gameplay, ties occurred more frequently than expected, while both players had fewer decisive outcomes compared to the theoretical model.
To sum up, this experiment explores probabilities through 30 details can carry out in 3 separate trials. Each game begins with a reset ball to ensure fair and consistent conditions. The outcome is as win, 0 win, and ties also were recorded to observe how often each result occurred. Using this data, both theoretical and experimental probability we compared with theoretical probability based on equal chance and experimental probability based on actual gameplay result. Overall, the experimental show how probability concept apply in real situations, revealing how strategy run, handlers, and expect outcome interact in disaster game.